Good afternoon, everybody. We're here today with Dr. Michael Wagner from the Department of Fisheries and Wildlife, and I'll let him introduce himself and tell you a little bit more about what he does.
Hi, everyone. I am a broadly trained aquatic ecologist. My background is actually in marine biology and oceanography. I didn't come to freshwater work until my PhD, and I can't fully explain to you why I do what I do right now in the Great Lakes. What I do right now is study the behavior of invasive fishes and try to use that as a lens to discover new and interesting ways to control sea lamprey using means that are benign for the environment, so alternatives to things like pesticides. And I say I can't fully explain to you why I ended up here because prior to coming here at Michigan State University, I had never studied the sea lamprey, which is an invasive species of great interest to us in my lab. I'd never worked on the Great Lakes, and I'd never worked on the question of chemical communication, which is a deep theme in our research. Chemical communication is how a lot of fishes and other aquatic organisms learn things about their environment and other individuals through the use of odor that's transferred through the water. But the reason I came here is because departments like Fisheries and Wildlife purposefully try to solve problems that are of importance to society, not simply answer questions that are of interest to science. And so that realm is one that I wanted to work in this challenge to come up with new and interesting ways to control sea lamprey to benefit all of the peoples living in the Great Lakes Basin was of great interest to me.
Right. So what do you teach in Fisheries and Wildlife?
So the principal course I teach to undergraduates is stream ecology. So this is the ecology of riverine ecosystems. And the approach that I take to the class is the same approach that I take to my research and everything else that's done in my lab. The course attempts to develop a fundamental understanding of how the ecosystem functions, and then to use that understanding to investigate, think about how human beings interact with the ecosystem and how we might manage the ecosystem in a way that maintains its natural function, but also maintains the values that it provides to human society. And so it is fundamentally an ecosystem-based class. I also teach other courses periodically, sometimes on invasion biology, sometimes on animal behavior and the role that it plays in conservation biology, sometimes teaching at the undergraduate level at the intersection between environmental science and public policy through FW 181. And also something I'm very interested in is how to present science to varied audiences in a way that makes the information useful to them. And so I teach courses occasionally on how to do things like effective scientific presentation.
Great. So what got you started in biology and eventually in Fisheries and Wildlife?
Well, as I mentioned earlier, I started, my undergraduate degree was in marine biology, but I didn't start in a marine biology major. I actually started in astrophysics. And I had a weird and interesting thing happen to me in my sophomore year. And that is, up until that point in my entire life, I could just look at it all and it made sense to me. And then when I got to about what is the second or third semester of calculus, where it starts to get abstract, suddenly it didn't make sense to me anymore. And I was stunned by the realization that I had no idea how to learn math. And this was actually a great eye-opening moment, even though it was terrifying at the time, sort of realizing you're in the wrong major and in the wrong place. And that is, I discovered something about myself that's probably at the core of everybody who has an interest in science. And that is the thing that we most share with each other, is curiosity about how the natural world functions. And I realized that I would love to explore that in marine ecosystems. And I really wanted to be in environments where I could get my hands on the thing that I was studying. And that led me into marine biology. But fundamentally, what led me to a career that deals with problems at the interface between human beings and natural ecosystems is what happened after undergrad. I didn't go straight to grad school. I was encouraged to do so by professors, but frankly, I was burnt out and ready to do something different. And I went and worked for the U.S. Environmental Protection Agency for about 4 years in one of the regional offices. I was in Dallas, Texas. This is where most of the oil and gas industry in the country is concentrated. And I came to a really deep realization that industry was extremely well prepared when they came after the EPA and came after environmental regulations. They had very good people that were paid a lot of money and were extremely well trained. They knew what they were doing. The agency had to rely on academic scientists to essentially be advocates for the natural environment, which is something that academic scientists are fundamentally uncomfortable doing and often completely unwilling to do. And so the agency wasn't fully prepared. And I realized that what we need if we're going to successfully negotiate this unending debate between people and nature about how we're going to coexist is we need scientists who are willing to engage in the process of human decision-making, work with agencies, work with interest groups, work with stakeholders. And that fundamentally is what separates fields and departments like fisheries and wildlife from more classical departments like zoology or integrated biology that are principally interested in the science.
Great. Yeah, so I actually myself started as a mechanical engineering major for a year and a half, and midway through my sophomore year, realized that my dream of going back and studying birds after I graduated didn't need to wait to be a dream until after I graduated, and decided to start studying birds and eventually tropical rainforests, during that second year as an undergraduate. So yeah, not everybody comes to it immediately, but you're right that curiosity is a really important part. So you mentioned, kind of from the science perspective, one of the things we need to be able to do is be better prepared to address issues. But what do you think really are the major issues or the single most important issue that's facing fish and wildlife conservation and management today?
I think it's actually shifting human values, right? So we've all heard this term Anthropocene being thrown around, and that's a scientific, again, sort of geological and biological expression of the observation that the world is in every square inch affected by human activity, human behavior, and human decisions. And the interesting thing is, for folks in my generation, so I'm happily a Gen Xer, we were trained by people who study conservation biology with sort of a single goal in mind, and it still permeates conservation biology, and that is the preservation of biodiversity. And the consequence of that perspective is a belief, and that belief is that the historical pre-human condition of the planet is the desired condition, and that we ought to be striving to achieve as close to a replication of that as we can. I don't think that value permeates the more recent generations. And the reason is because people that are millennials, people that are in Gen Z, probably have never interacted with an ecosystem that doesn't have several non-indigenous species in it, and several invasive species in it, and a very powerful footprint from human activity. That to them, and in truth to science as well in many ways, is the normal state of ecosystems now, what we call a hybrid ecosystem, right? Where there's sort of these natural components and human components. And so I think the greatest issue facing us is that we have a generation of decision makers that are rooted in a value system that's about preservation and return to biodiversity, or in some cases rooted in a value system that just says this is an economic resource that we should exploit to the extent that we desire. But the values of the most recent generations are that we should be negotiating across these systems, that we should be thinking about ecosystems and how we use them and interact with them. We shouldn't necessarily be striving for some primordial state, because frankly, it just doesn't make sense. You can't achieve it without people. And so I think that value shift that's happening in the populace, but isn't yet happening in the highest levels of leadership and agencies, presents a really substantial challenge. And it's also why we desperately need people coming out of undergraduate programs and graduate programs who have deep understanding of both how natural ecosystems function, but also how human decision-making systems, governmental systems, values, perspectives, function as well.
Oh yeah, that's really interesting. Thinking about our students today and the challenges that they're going to face, but that they'll hopefully come at it with a more evolved perspective than especially the generation that taught us. But even our generation, we really struggle with how to put humans into these ecosystems that we're trying to protect. So kind of to wrap up, just had a question whether you had any insights or advice for fisheries and wildlife students, knowing that these are FW 101 students getting ready to embark on hopefully a major in fisheries and wildlife and eventually a career.
Yeah, my number one piece of advice would be do the hard things. And by that I mean, it's easy and fun to do things like techniques classes, and you should do some of those things. But if you do want to have an impact in this field and in this life, if you do want to help human beings and help nature sort of find their way over the next 50 years, then your time at the university allows you to dive deeply into the difficult subjects of how organisms and ecosystems fundamentally operate, and how human systems and values and decision-making fundamentally operates. Those classes are hard and they take a lot of effort. And you're not even sure what you learned at the end of it. It won't sort of manifest until later in your career. But the difference between taking those hard classes and thinking deeply about what you're doing versus taking a techniques class that might get you in the field and do something fun is that what we need from you when you get into the field is not to be able to delineate a wetland on day one or sample fish on day one. Frankly, people can teach you how to do that on the job, and they might do a better job of it than we do because they use those techniques every day. But by diving deep into the core aspects of this field, what it will allow you to do when you're on the job is judge whether the right techniques are being used and innovate and come up with new ways of doing things that's going to be more effective because it derives from your fundamental understanding of how nature operates, how humans operate, and how they interact with each other. So my advice is take those hard classes. Take those hard classes, and when people ask you, why did you take, this difficult organic chemistry or theoretical ecology, and got a 2.5 when you could have taken something else and got a 4, tell them it's because you need to know this in order to be successful in your career. And that is an answer that those of us who hire people as graduate students or hire people as biologists at agencies want to hear, because we can teach you how to pull a net, but we can't teach you how to think once you're on the job.
Well, great. Well, thank you. Yeah, that's really important advice. And I know students sometimes do try to shy away from the more challenging classes or question, why do I need to know about human dimensions of fisheries and wildlife, when the reality is that those classes are the ones that really do help you have the broader skills that your employers are looking for, or your professors for graduate school. So, well, I'd like to thank you for your time today and really appreciate you giving us an interview. Just quick question, what is the background behind you?
So that is the eastern shore of Virginia. So you may not know this, folks may not know this, but Virginia is busted into 2 pieces, the same way that Michigan is. It's got a piece on the Atlantic coast just north of the main part of Virginia called the Eastern Shore. I did my master's degree at the Virginia Institute of Marine Science, and a lot of my work took me into the marshes and areas on the Eastern Shore, and that's what's pictured behind me.
Wow, great. Well, thanks again, and I really appreciate it.
Sure, thank you.